them to run once. So and those things are stuff like pruning logs to stop your log tables from growing. Oh, okay. Whoops. Now the sound's coming through. I'm just going to mute that. Right. Suddenly the sound started happening on YouTube and it really threw me off. I didn't realize it wasn't muted before because there wasn't audio coming through. Yeah. So should I back up then and start again? Yep. How leadership ties into that. Yeah, right. So what I was saying is you'd have an HA controller, or you'd enable HA on a Juju controller, which would create 3 more. All right, capped collections now. Okay, thanks, Tim. Apparently, we don't need to prune logs, but there are other things that. Yeah, okay, machine provisioner. I'll use that as the example, and I get back to that. Right. So controllers. You might want to run more than one controller machine so that if a controller machine blows up or dies for any reason, that you can still use Juju while fixing that controller, and you haven't just lost all of your workloads. Or you wouldn't lose your workloads, but you wouldn't be able to, add new units or deploy new applications. So the thing that So when you go Juju enable HA, it would provision more machines and run controllers on them and incorporate those controllers into a cluster. The part where leadership comes in is that we have jobs that run on each controller for each model on a specific controller, but we don't want to run more than one of them. So for example, Tim P pointed out the machine provisioner keeps track of what machine should be in a model. If it sees a new machine added to a model, then it asks the cloud API to make a new machine. We don't want that to happen 3 times, obviously, if you've got 3 controller machines. So one of those controllers need to be responsible for that specific model. And so we have a leadership system where for each model, we have workers that try to run on every controller. And the first thing they do is try to grab a lease for that model. And it's whoever requests it first wins situation. Generally, what happens is the model gets added to the database. All of the controller machines try to grab the lease. One of them gets it. And then from that point on, as long as that controller is still running, it will be responsible for that model. But the nice thing is that, oh, sorry. Yeah. Right. Mm. Yep.
Sure. Sure. So a Juju application is a single piece of software that may be running in multiple actual locations, but it is something like a MySQL database, a custom-built web server app, some piece, microservice or whatever of your overall whatever you're doing, and that application instances of it might be running on individual units, where units are basically machines. They might be virtual machines. They could be containers if we're talking about Kubernetes. They could be actual physical machines, but they're basically instances of an operating system that might be hosting one or more applications, and the applications might be spread over one or more units. So those are the two levels of abstraction where Juju kind of handles your your machines and your units. Cool.
Right. That's not where I thought you were going with this question. I was sort of going to come back to the other question around leader set and leader get. We had a key thing is that the leader set and leader get commands that were used in the past were used for effectively a charm to multiple instances of that charm, which are the units that are deployed, to communicate between themselves to negotiate stuff. So you'd have, if you had multiple instances of an application or multiple instances of your application running, which is multiple units, one of them will be designated the leader, and that's something that the Juju controller keeps track of. The charm hooks that are being executed, they need to ask, am I the leader or not? So there's the question, so there's one of the commands that they can run is leader, which will then tell them whether or not they're the leader. Only the leader can set information for, conceptually, that you'd have a collection of data that the leader sets. Right, so there's like a leader set, which is the leader can set data, but anyone can get data. Now, recently, I think it was 2.7, we introduced the concept of an application data bag, which normally when you would have applications that are related together, there would be a little data bag for every thread of that relation. So if you had 2 units on one side and 3 units on the other side, that's a total of, each unit would have a different data bag for each counterpart that they had. Frequently, what you're actually setting in that information for the other side to consume was the same. So instead of trying to have all of those units coordinate to send the same information across, they added the concept of an application data bag so that you would set that information. You'd set that information in once, but the leader would be responsible for setting that bag, setting that data. So we had the leader set, leader get were the old way of setting leadership data, and the new way is effectively to have a peer relation and use the application data bag associated with that for moving forwards. So if you're using the new operator framework, all of that's hidden from you, and it just does the right thing, which is a convenient thing.
I think a key thing is that that sort of the difficulty with leader set and leader get was that because you needed a peer relation, you had to have this complicated dance for all the units where they would get the leader information and then forward it on to the counterpart on the other end of a relation. And now with the application data bag, the extra bit is that when the leader sets that information, the other side of that relation, all of the units on the other side can see that information as well. So that really simplifies writing charms that need to care about leadership, right? Yeah.
Right. So yeah, thanks, Tim. So the OpenStack charms is actually a project that is upstream in the OpenStack community, largely driven by contributions from Canonical and customers essentially that utilize the charms to deploy their production OpenStack. But if we kind of rewind a bit, the OpenStack set of charms, it's now grown to about, I think it's 50 or 55 charms in total, representing a very complex series of interrelated microservices, if you will, to deliver compute, network, storage, API, all in a highly available fashion. If you can imagine all of that, that sounds very complicated to set up, very difficult to manage, and so that's where Juju and Charms really shine for us, is making it so that operators, administrators, users, and developers can essentially take a group of machines or even a single machine and easily stand up a very complicated solution. So our relationship is of course we rely on Juju to facilitate the charms, and naturally we leverage all of the primitives that you guys are talking about in terms of applications and units and leader settings and all of the sort of glossary surrounding everything here. So anyway, it's critical for the success of that sort of an OpenStack deployment. Without such a tool, you have a whole lot of configuration management to try to string together with multiple different tools. And so again, that's where it really shines. All right.
Yes. Sure. So Microstack is OpenStack in a snap. It's a very quick way of deploying kind of a minimal version of OpenStack on a single machine, which was originally intended to help people who are developing OpenStack workloads kind of spin up a test environment. One of the things that it is nice for is actually testing Juju out against an OpenStack cloud. So Juju's a tool for interacting with various clouds. OpenStack is a cloud. And actually, one of our tutorials is for Microstack, is basically setting up a Juju controller on Microstack and deploying units with it. So you can kind of see you have your own mini cloud on this machine that you've put on your laptop, or I have a server living somewhere that I do a lot of work on. And then you can deploy basically any application you'd like to it that Juju can handle. Our example deploys Kubernetes because it was just entertaining to put a cloud on top of a cloud, but yeah, you're not limited to that at all. Yes, yes, yes.
will run off. Yes. Bye.
Right. Thanks, everyone. Take care.
Oh.
Cheers.
Well, I'm a small cog in a team of very talented people who are making this work. So Kubernetes obviously runs containerized workloads, and they suffer from the same problems that Juju solves in VM-based workloads. You have many components, all of which are deployed individually, but then have to be coordinated and related together to form, the entire solution. And managing the interdependencies between these many different individual deployments and the relations between them and making everything coordinate together is just as hard on a containerized workload as it is on a VM-based workload. There are differences, of course, but fundamentally the day-end problems, what do you do to manage and maintain a deployment after you've got the bits into the cloud and up and running, remain the same. So Juju offers the same modeling advantages and the same management advantages for Kubernetes as it does elsewhere, like OpenStack. So part of the attraction in using Juju to drive Kubernetes and manage those containerized workloads is that it offers the same model-based approach. It offers the same workflow, the same sort of paradigms that you would use elsewhere. So if you know how to use Juju to drive OpenStack, then it's not a stretch to then use Juju to drive Kubernetes from a user's perspective, even though the underlying technologies are radically different. So Kubernetes. Well, Chicharman's a different story. It's compared with, say, what an end user would see. If you want to talk about a workload, maybe think about KubeFlow, which is 28 or 30 odd individual components or Docker images, all deployed and running together. If you just as there's Microstack, there's also Microstack, which is a great way to get a Kubernetes fully API compliant Kubernetes cluster running on your local machine. You snap install Microstack. You can then Microstack enable KubeFlow, which internally bootstrap a Juju controller into that Microstack cluster on your laptop, and then deploy the full KubeFlow stack there, so that you have a fully running KubeFlow solution locally with a couple of commands. And the thing that makes the other thing. Oh, sorry, I was just going to say the other big advantage of Juju driving Kubernetes workloads is that quite often, and you will have the case that Kubernetes is relatively new, and there are some workloads that just haven't yet been retooled to run in a containerized environment, or just for legacy reasons or whatever, still run best on bare metal or VMs. And so, how do you bridge the divide between running heterogeneous solution consisting of some containerized workloads and some bare metal or VM-based workloads? Juju can bridge that gap because it supports the ability to deploy containerized workloads in one model, VM or bare metal workloads on NAS or OpenStack in another model, and using relations between those models, you can integrate those different types of workloads together and manage them using Juju as a single tool, as a single management solution. So here's a very simplistic example. You might have Postgres running on NAS, and you might have some web service or something else that needs a database running as a containerized workload in Kubernetes. But you want to have that containerized workload talk to Postgres running in a totally different cloud on NAS or whatever. And Juju makes that possible using the same tooling, the same modeling, the same workflows, everything that you would be used to normally with Juju over the past X years. You can do now with Kubernetes. It's just another component in that solution. So it's all sort of seamless and single point of view onto that heterogeneous workload. It has. It's slowly rising. Yeah, sorry, could I just make one small point just to pick up? Yeah, sorry. So it's still early days for Juju on Kubernetes. We're still learning lessons. We're still refining how we do things, and because it's only a relatively new deliverable, there's not a great breadth of workloads that have been charmed up. So it's not like the VM world where there's charms for many workloads that you want to run. It's still something new. It's still undergoing active development, and I guess watch this space in the next few months as it matures to the point where we can get a more rapid development of workloads that we care about.
No, sorry, I was waving at him off. Darn.
Yes. So we're actually very actively working with folks who are, in two different workflows. So one who are just building their first charm, and then two who have existing charms that were perhaps written in a different framework, and updating them into the new framework and what that process could look like, and why it's beneficial. So no updates that I want to bring forth at the moment, but I think if there are folks who are in either of those workflows, we would love to chat one-on-one, bring some of our experienced operator framework folks into the conversation and help guide you or understand where the pain points are, so we can kind of build some more documentation or tutorials and training around them. We'd love to hear that kind of feedback. I'm super comfortable with that. Also my Twitter, my Facebook. Yeah, that's how much I'm excited about some of this feedback. So, yeah, 100%.
Mm-hmm. Sure. Well, so okay. Maybe go the other way. A minor release is, so 2.7 to 2.8, which is coming out soon. In a minor release, we'll often add new features, but we won't break backwards compatibility. So, there won't be things where old chunks won't work with the new version of Juju, for example. So, but we're adding lots of new features to 2.8, for example. So, what's an example of a feature that we're putting into 2.8? Well, new other, yeah, that's right. Yeah, that's one thing. Is that the action, the way the UI, particularly for and the sort of data structure for actions, is sort of changed. It's a new sort of way of grouping those things together. Ian, what are some other things I'm trying to think? One thing that I've been working on is a new restore tool that's sort of outside of the controller, so that to make it a lot easier to do restores of backups, which was previously a bit tricky. Mm-hmm. Oh yeah, you were talking about that. Mm-hmm. Or some units might appear, like they might still be spun up, right? But it's yeah. Mm-hmm. Yeah, and they'll be saying blocked, waiting for a CA certificate authority, right? So because they'll say, oh, well, I can't do anything until I'm related to a certificate authority, but no. Mm-hmm. Right, right. Mm-hmm. Yeah. Yeah, I mean, obviously we'll do bug fixes in the minor release as well, but but yeah, like generally we try not to. For example, one of the internal things we have, the controller offers an API that all of the other agents talk to. We try not to version the API facades, so that API is versioned, so older agents can talk to a newer controller. For example, if you upgrade a controller, then but you haven't upgraded the models yet. All of those agents are the older version. They're talking to the newer controller, so they talk to the old version of that facade. Normally, what happens is in that API, when we need to add new features to it, to keep that backwards compatibility, we will add a new version of that API. And so that's something that we try not to do in point releases, although sometimes we have to fix particular bugs. But so that's probably the main distinction. Is, yeah, point releases should only be bug fixes. And we try very hard to do that because it makes the point release much safer to upgrade to a point release so that people can
no, that's a fairly accurate summary. So, any X dot Y dot Z, anything with a Z in it has to be bug fix only, unless there's something that's sort of very self-contained and targeted to solve a particular field issue. We might introduce something that might be considered a new feature if you want to think about it like that, but it's driven by the need to fix a bug or an issue, say, in the field. And then every release cycle every 6 months or so will go from X dot Y to X dot Y plus 1. So we're about to release 2.7 6 months ago. Sorry, 2.8. And 6 months ago we released 2.7. So we tend to sort of have larger feature drops in those regular 2.7, 2.8, 2.9 releases. And then when we get so feature flags, we have a couple of different ways that feature flags are implemented in Juju, but in this particular case, this is something that can be activated. It's only relevant to a client. So once you deploy Juju 2.8, out of the box, you'll still get the current default behavior that has existed in Juju previously. That enables things like scripts, which rely on executing and monitoring actions to work unchanged. But as a particular user, if you'd like to take advantage of the new UX, and we recommend that everyone does because it's much nicer, and you get the ability to do things like cancel running actions and things that you couldn't do previously. We recommend that you simply set this environment variable, Juju underscore features equals actions dash v2. It will be documented. But if you do that, you then get the new UX via the CLI. And you did that on a per client basis. So if you're an individual and you don't want to use the new UX, you don't have to, even though we recommend you do. If you've got scripts running somewhere that rely on the existing CLI, they can continue to run. But on your particular machine, you can activate the new UX. And because it's client only, individuals can make their own choice using the same deployed Juju controller. So it's a client only.
Especially if you're running an action across multiple units of an application, right? That's where it really comes into its own because it sort of groups things much more clearly. That's my
and it's just fundamental fixes. Like previously, for whatever reason, we were excluding standard out and standard error that the action may have printed when it was running. We extended those from the results that you could then see afterwards, things like that. So the improvements are too numerous to mention here. It'll be part of the release documentation, but it's a much nicer experience.
Thanks, Tim.
Cool. Thanks, Tim.
Thanks, guys.
See you, everyone.
See ya.
Catch you later.